For the Introduction to Epidemiology course, this is the lecture recording for the module Measures of Association, and this is segment 1. So the outline for this overall module and lecture topic will talk about several different types of measures: risk ratios and risk differences, rate ratios and hazard ratios, and then odds ratios. And finally, we'll talk about the precision of these measures and using confidence intervals to represent that. The objectives for the module is that you will be able to calculate and interpret risk ratios, risk differences, rate ratios, and odds ratios. So given this is the introductory course, our emphasis is going to be on interpreting these measures and not so much doing a lot of calculations yourself. And then the second bullet, the second objective, is that students will recognize which measures should be used depending on the study design and type of data. And finally, students will be able to interpret confidence intervals and recognize information that they provide that a p-value does not. So we'll start with the topic of the segment on risk ratios and risk differences. This slide shows some terminology for measures of incidence and measures of association in a randomized controlled trial or cohort study. So in this course, we've already addressed measures of disease frequency and how incidence is measured. So in the table, we see that the first two columns on the left, the type of denominator might be a count, and then in the second column, the measure of incidence that you can create based on a count denominator might be called a risk. It might be called a cumulative incidence, and it might be called an incidence proportion. And again, these are all things covered in a previous module. So then the next column, the third column, shows what, in the fourth column, show what's going to be new for this module, which are going to be the measures of association. So we'll have relative measures of association and absolute measures of association. So the relative measure, when you have a count denominator, could be called a risk ratio. You might also call it a cumulative incidence ratio. The absolute measure, also based on the same measure of incidence, the risk, would be a risk difference. And the absolute measure could also be termed a cumulative incidence difference or even an attributable risk. So looking at the lower half of the same table, if the denominator on the far left column, the type of denominator is a person time, then as addressed in a previous module in this course, the measure of incidence would be called a rate, or you might also call it an incidence density, and a different type of measure of incidence would be a hazard rate, or a measure of hazard rate is actually a measure of hazard, but it's one of the units that can be compared to create a measure of association. So in the third column on the lower half, what measures of association are based on a person-time denominator, and those include a rate ratio, an incidence density ratio, which are actually equivalent, different terms for the same measure, and then a hazard rate ratio, which is something else, which we'll get to later in the lecture. And then the absolute measure would be called a rate difference. So how are we going to calculate this relative measure of association in a cohort study or a randomized controlled trial? It would be the same, using count data in our denominator. So this slide shows the 2x2 table that we've seen frequently before, where we have exposure status, top row and bottom row, yes or no for exposure or treatment, and then disease status, yes or no, in the columns. So the association between exposure and disease can be measured as the ratio of the incidence in the exposed to the incidence in the unexposed. So the incidence in the exposed, or the top row, is the number of incident disease events A divided by the total in the exposed cohort, A plus B. The incidence in the unexposed or untreated is letter C, those with incident disease, divided by the total of C plus D. So comparing those two incident risk quantities, we come up with what we call the risk ratio or a relative risk, and sometimes also called the cumulative incidence ratio. So an example of how that's reported in a study, this is a table from a publication that happened to be about lymphedema outcome at 12 months in a randomized trial of weightlifting intervention for breast cancer survivors. So looking at the main columns of the table, we have weightlifting and control and the counts, and then the number and percent with, so the total number of patients, then the number and percent with a change in their interlimb volume. So the measure of incidence here would just be a risk. So 8 out of 70 in the weightlifting category, or 11%. The risk is 11%, or 11 per 100 if we want to make it sound more epidemiological. And then in the controls, 8 out of 69, which is about 12%, and so the risk ratio comes out to 1 or no difference. So this phrase cumulative incidence ratio is a way of expressing a risk ratio, and that phrase is used a lot, I've noticed, in epidemiology textbooks. They like to call this measure of association a cumulative incidence ratio. I had a hard time finding a published paper that used this phrase. They almost always just say risk ratio or even relative risk. So you have to take a look at the methods and take a look at the tables and think about how the measures were calculated, because you may see some terminology differing across publications. So why is this the right measure? The count denominator and the cumulative incidence ratio. What are the study characteristics that make the cumulative incidence ratio the correct measure for these data? Well, first of all, follow-up was essentially complete. I read the other parts of the methods and they lost almost no one. And then all the subjects were observed for the same period of time, so there's no real value added in using some kind of person time denominator, because every person had about the same amount of time. And then the outcomes were really measured at one time point. There was a final study visit, and that's when that arm volume difference compared to baseline was measured. So it's not as though you could have had some kind of Kaplan-Meier curve or time to failure, because the outcome wasn't the way the study was designed. The outcome was not going to happen at different time points along the way. It was just one end of study measurement. So this is a randomized trial that is using a cumulative incidence ratio as its main measure of association. Another example that also used a count denominator, and this is also a randomized trial, outcomes of pregnancy according to treatment assignment. And there was a progesterone and a placebo group for prevention of recurrent preterm delivery. So looking at the table, delivery before 37 weeks of gestation happened to 111 in the progesterone group with a total N of 306. So the risk in the progesterone group was 36%. And then the placebo group, 84 preterm deliveries out of 153 total N, so roughly 55% risk of preterm birth in the placebo group. So then the relative risk comparing those two groups is 0.66, or in other words, 0.66 the progesterone group had an incidence that was a ratio that was a proportion of 0.66 of the placebo group, or preterm birth risk was reduced by 34% in the treatment group compared to the placebo group. And again, that preterm birth example, they used the term relative risk. Relative risk is sometimes a generic term that can be used to represent one or many different measures. So let's go ahead and plug the numbers into Stata, the numbers we actually saw in that table in the previous slide, to confirm that the calculation is risk ratio. And so this is the command, the CS or Cohort Study I immediate, and I've just plugged those four numbers in, and Stata produced the rest of that output: the exposed, the unexposed, the cases, the non-cases, the risk in the exposed and unexposed group, and down below we see the risk ratio of 0.66, which is the same thing reported in the paper. So the ratio is a relative measure because we're dividing. One divided by the other is the relative measure. The alternative is to calculate an absolute measure of association in a cohort study, or in a randomized trial using count data. So in both cases, we're going to calculate the incidence in the exposed or treated, and the incidence or risk in the untreated or unexposed. So those two quantities would be A over A plus B, and then C over C plus D. Those would be the two separate risks. And this time, instead of taking the ratio by dividing them, we're going to subtract and get the difference. So that's going to give us the risk difference. An example, again, a randomized trial. Example of reporting a risk difference: procalcitonin to reduce patients' exposure to antibiotics in intensive care units. So the two columns are the treatment group, procalcitonin, and the control group. And then the endpoints were mortality. So let's look at the first row: 28-day mortality in the procalcitonin group, 65 deaths out of 307 in that group. So the risk was 21% mortality. The control group, 64 deaths out of 314. So the risk was 20.4% of mortality in that group. So if we subtract, so they, again, another paper that chooses to express its risk as a percentage. As we talked about, you can choose different denominators for your risk. You could say the risk per 1,000 or the risk per 10,000. And in this type of study, it actually makes a lot of sense to say the risk per 100 or percent. So the difference between those two percentages is 0.8%. So very little difference between those two groups. And so you can see that they just subtracted 20.4 from 21.2. Another example of reporting a risk difference, again, a randomized trial: compression-only CPR or standard CPR in out-of-hospital cardiac arrest. And I believe the intervention was carried out by EMTs, by emergency medical technicians in the ambulances. They were given some kind of a note that randomized each patient that they came across that they were treating, whether that was somehow randomized to be in the compression only versus standard CPR group. So let's look at, so the two columns are the compression only CPR group and the standard CPR group. And the first row is 30-day survival as a primary outcome. So 54 out of 620 were alive at 30 days, so 8.7%. So that's kind of the inverse of a risk. It's a proportion surviving of 8.7%. And then standard CPR, 46 out of 656, or 7%. And so subtracting those two percentages, you get a risk difference of 1.7%, demonstrating the equivalence. And so this risk difference, I feel like I should mention, because people now in the clinical literature and randomized trials are more and more starting to report a quantity known as number needed to treat. And so the number needed to treat is calculated based on the risk difference. So this equation shows that the number needed to treat based on the risk difference and some selected time point is really 1 over the risk difference, the inverse of the risk difference, or 1 over the difference of the proportion surviving in the two groups. So I'm not an expert on number needed to treat, but just wanted to point out that our risk difference, a lot of the quantities we talk about in epidemiology are just and proportion surviving are what feed into number needed to treat.